Hello all, this is Sandeep Kumar and I welcome you back to my YouTube channel Concepts of IIT Maths. We are in the chapter of inverse trigonometry and this is the fourth video. So in our previous videos we have already seen the introduction to inverse trigonometry and then the graphs of inverse trigonometric functions and properties of inverse trigonometric functions part 1. So in part 1 we have discussed what is sine of sine inverse x, cos of cos inverse x, etc. Sine inverse of sine x, cos inverse of cos x, etc. And then what is sine inverse of minus x, cos inverse of minus x, tan inverse of minus x, and so on. All these three properties were discussed in previous video, and in this today's video we will be discussing about the inverse trigonometric functions of reciprocals of x. That means what is sine inverse of 1 by x, cos inverse of 1 by x, tan inverse of 1 by x, and so on. Then we will discuss about the next property, which is what is cosecant inverse of sec theta, what is sec inverse of cosec theta, tan inverse of cot theta, etc. And finally this one more property, what is it, what is secant inverse of x plus cosec inverse of x. So totally here we are going to discuss about three properties. This is the first property, second property, and third property. In today's video we will discuss about three properties of inverse trigonometric functions. So let us see how to prove those properties. Keep this in mind. If you are clear in proving these properties, certainly you will be successful in solving advanced model problems. Keep this in mind. Let us be stronger in the concepts. And at the end, if needed, we will see some problems on these properties. In previous video we had theorem 1 and 2 and this is theorem 3. So what does theorem 3 says? So it's about inverse trigonometric functions of 1 by x. Okay now. So it's about inverse trigonometric functions of 1 by x. So the first formula says that sine inverse of x is equal to, if sine inverse becomes cosec inverse, it is cosec inverse of 1 by x. Understand that this x, okay now, x belongs to where? X belongs to the domain of sine inverse function. What is it? X belongs to minus 1 comma 1 except one input. In place of x I should not take one value. What is it? Look at this. X cannot be 0. Okay now, except 0. Keep this in mind. Okay now. So x can be any number from minus 1 to plus 1 except 0. So sine inverse x is equal to cosec inverse of 1 by x. Similarly, we can also say that cosec inverse x is equal to sine inverse of 1 by x. You got it? Where x belongs to? Where x belongs to what? X belongs to the domain of cosec inverse function. What is it? X belongs to minus infinity comma minus 1 union 1 comma infinity. Similarly, we can say that cos inverse x is equal to sec inverse of 1 by x, where x belongs to the domain of cos inverse function, which is minus 1 comma plus 1 except 0, because 0 is not accepted here. Similarly, sec inverse of x is equal to cos inverse of 1 by x, where x belongs to the domain of sec inverse function. What is it? Where x belongs to minus infinity comma minus 1 union 1 comma infinity. And finally, what is it? Tan inverse x is equal to, here tan inverse x has two different formulae. Okay na? Tan inverse x is equal to, it is a cot inverse of 1 by x if x is positive, and it is cot inverse of 1 by x minus pi, 1 by x minus pi if x is negative. Let us see the proofs of these. Okay, now I'll pick some of them and I'll prove it. You can prove the remaining. It's very easy to understand. It's very easy to prove also. So remember these formulae. Okay, now remember these formulae, but let us also see how to prove them. Okay, I'll prove the first one and third one. Okay, you can try proving the second one and please practice the proofs. A simple proof where we will prove that sine inverse x is equal to cosec inverse of 1 by x, where x is in the domain of the sine inverse function except 0. What is it? See, the proofs are very much similar as you keep seeing the proofs of all these properties. First, what I'll do? Let sine inverse x is equal to theta, where x belongs to minus 1 comma plus 1 except 0. Then dear students, if then theta is, if x is in the domain of sine inverse function, then theta is the range of sine inverse function. What is the range of sine inverse function? Then theta belongs to minus pi by 2 comma plus pi by 2 except 0 degrees. Correct? Okay. So now since x is in the domain of sine inverse will go to the right side, it becomes sine. Or else, as we have discussed in the previous video, you apply sine on both sides and you get this. You got it? Actually we are using theorem 1, but this is fine. Okay na? So next, x is equal to sine theta, but I want it in terms of cosec. So what I'll do? Take reciprocal on both sides. 1 by x is equal to cosec theta. 1 by x is equal to cosec theta. Now theta is between minus 90 and plus 90, which is in the restricted domain of cosec function. Correct? So this is in theta is in the restricted domain of the cosec function. Therefore cosec will come to the left side and it becomes cosec inverse of 1 by x. Cosec will come to the left side only when theta is in the restricted domain of cosec. Okay na? And what is left out here? Theta. So theta is what? Sine inverse x. Therefore sine inverse x is equal to cosec inverse of 1 by x. Similarly, you can prove that cosec inverse x is equal to sine inverse of 1 by x. Okay na? And at the same time you prove the second one. What is it? Cos inverse x is equal to sec inverse of 1 by x. Sec inverse x is equal to cos inverse of 1 by x. You can prove it. Okay. In this particular theorem, I will prove that tan inverse x is equal to cot inverse of 1 by x, and the other answer that we will prove it now. See, generally we might mistake that tan inverse x can always be written as cot inverse of 1 by x, but that is not true. Okay, tan inverse of x is cot inverse of 1 by x only when x is positive. And what if this x is negative? You should write cot inverse of 1 by x minus pi. Okay, so let us prove this. Case 1 is when x is positive. So let tan inverse of x is equal to theta. Now as you see, x is positive, x is greater than 0, x is in the domain of tan inverse function. So therefore tan inverse will go to the right side. X is equal to tan theta. Tan inverse, if it goes to the right side, it becomes tan theta. And observe one thing, if x is positive, then theta belongs to 0 comma pi by 2. If x is positive, then theta belongs to the first quadrant. If x is negative, then theta will be between minus 90 and 0. How I got this means, tan inverse x range is between minus 90 degrees and plus 90 degrees. Okay, now tan inverse x range is between minus 90 and plus 90. If x is positive, then I will take the angles between 0 and 90, and if x is negative, I will take the angles between minus 90 and 0. Okay, now keep this in mind. Okay, anyhow, from tan I want cot, right? Let us take reciprocal on both sides. 1 by x is equal to cot theta. And again check that theta is between 0 and 90. What is the restricted domain of cot theta? The restricted domain of cot theta. What is the restricted domain of cot theta? We have discussed in previous videos. It is between 0 comma pi. Between 0 and 180 degrees. Clearly 0 to 90 is in the restricted domain of cot theta. This is in the restricted domain of cot theta. So that means theta is present in the restricted domain of cot. So then cot will fly to the left side. It becomes cot inverse 1 by x, which is theta. Cot inverse 1 by x is equal to theta. Theta means what? Tan inverse x. Okay, now this is only one case. So tan inverse x is equal to cot inverse of 1 by x when x is positive. Now let us see what happens if x is negative. Please observe carefully. The second case where x is negative. As usual, let tan inverse x, the question is equal to theta. Now if x is negative, then theta belongs to minus 90 comma 0. It is between minus 90 and 0. You got it? Because the range of tan inverse x is between minus 90 and plus 90. If x is positive, I have taken between 0 and 90. If x is negative, I have taken between minus 90 and 0. Okay, now so keep this in mind. If x is positive, I have taken first quadrant angle, and if x is negative, I have taken fourth quadrant angle. So once again I am saying, if x is positive, I have taken first quadrant angle. Theta is between 0 and 90. And if x is negative, then theta is between minus 90 comma 0. Okay, now so keep this in mind. This comes from the range of tan inverse x. Okay, so fine. Okay, so now x is in the domain of tan inverse function. Therefore tan inverse will go to the right side. X is equal to tan theta. X is equal to tan theta. But I want cot, right? So let us take reciprocal on both sides. X becomes 1 by x and tan theta becomes cot theta. Then student will say, sir, I will take cot to the left side. No, not always. Not always. When can I take cot to the left side? When theta is present in the restricted domain of cot function. What is the restricted domain of cot function? The restricted domain of cot function, the restricted domain of cot theta is between 0 and pi. But observe that theta is between minus 90 comma 0. This is not, it is not in the restricted domain of cot theta. So the theta is now between minus 90 and 0. This angle is not in the restricted domain of 0 to, is not in this particular interval. So what to do? Let us come back to the concept that we discussed yesterday. For the first quadrant angle, I will take theta. For the second quadrant angle, I will take pi minus theta. These two are taken anti-clockwise. Next, for the fourth quadrant angle, I will take minus theta. And for the third quadrant angle, I will take theta minus pi. These two are considered clockwise. Okay, now anti-clockwise positive angles, clockwise negative angles. You got it? Now, cot theta is positive in first quadrant and also third quadrant. Cot theta is positive in first quadrant and third quadrant. So I can write cot theta as, cot of theta minus pi. Cot of theta minus pi. Cot theta and cot of theta minus pi both are same only. Now check whether theta minus pi is in the restricted domain of cot function or not. How to check it? So theta. So theta is between minus pi by 2 and 0 degrees. Theta minus pi means I should take minus pi. Theta minus pi means even here also I will do minus pi and here also I will do minus pi. So theta minus pi is between minus 3 pi by 2 and minus pi. Theta minus pi is between minus 270 and minus 180. Again, minus 270 comma minus 180 is not in the restricted domain of cot. So this is a failure. We cannot take theta minus pi. So when theta minus pi is a failure, you consider pi plus theta. That means instead of taking the angle in clockwise, I am taking the angle anti-clockwise as usual. So theta minus pi is an angle in third quadrant. Pi plus theta is also angle in third quadrant. Now let us take cot theta as cot of pi plus theta. See what happens now. Theta is between minus 90 and 0. Then pi plus theta means what? Simply adding pi. Pi plus theta. Pi plus theta is between what? Pi by 2 and pi. So pi plus theta is between pi by 2 and pi. Pi plus theta is between pi by 2 and pi. And the angle pi by 2 comma pi is a subset of this. Pi plus theta is between 90 and 180, which means the angle between 90 and 180 is in the restricted domain of cot theta. So that means this is in the restricted domain of cot function. That's why cot will go to the left side now. So cot inverse 1 by x is equal to pi plus theta. So take pi to the left side. Cot inverse 1 by x minus pi is equal to theta, and theta is tan inverse x. So that's why tan inverse x is equal to cot inverse of 1 by x minus pi. Okay, when x is negative. So two formulae are there. If x is positive, tan inverse x is cot inverse 1 by x. If x is negative, it is cot inverse 1 by x minus pi. Okay, we will go with the next property with proof. Our next theorem, the next property, what is sin inverse of cos theta? What is cos inverse of sin theta? Next, tan inverse of cot theta, cot inverse of tan theta. Then secant inverse of cosec theta, cosec inverse of sec theta. So what are the values means? All these are equal to pi by 2 minus theta. All are equal to pi by 2 minus theta. All are equal to pi by 2 minus theta. All are equal to pi by 2 minus theta. But sin inverse of cos theta is equal to pi by 2 minus theta if and only if this theta is present in the restricted domain of cos function. Theta is present in the restricted domain of cos function. What is it? Between 0 and pi. Between 0 and, from 0 to pi. Similarly, cos inverse of sin theta is equal to 90 minus theta if and only if theta is present in the restricted domain of sin function. What is it? From minus 90 comma plus 90. Now I think you can complete it for the remaining. So in this case, what is theta, dear students? If and only if theta belongs to the restricted domain of cot function. What is the restricted domain of cot function? Between 0 and pi. And here theta belongs to the restricted domain of tan function. That means between minus pi by 2 and plus pi by 2. And here theta belongs to the restricted domain of cosec function. What is it? Between minus 90 comma plus 90 except 0. And here theta belongs to 0 comma pi except pi by 2. And if anyone are not familiar with this word called restricted domain, please visit the first video in this chapter. I have clearly explained what is the restricted domain of cos theta, sin theta, cot theta, all these things. And what is the domain of sin inverse x, cos inverse x, tan inverse x, etc. What are their ranges? I have discussed it very clearly. You got it. All these are our basics. Out of these six properties, I'll prove any two. Actually, one is enough, but let me prove two. You can complete the remaining. Let us see how to prove that sin inverse of cos theta is equal to 90 minus theta, where theta is between 0 and pi. Okay, dear students. Sin inverse of cos theta is there, right? Sin inverse as it is. In trigonometry, we know that cos theta is sin of 90 minus theta. Cos theta is sin of 90 minus theta. And if theta is between 0 and pi, then what about 90 minus theta? It is between what values? Let us see. So 90 minus theta. First of all, minus theta. If I multiply with minus, what happens? Minus into 0 will go here and minus into pi will come here. The values will be exchanged. These are our basics in inequalities. Not only minus theta, we have 90 also. 90 minus theta. So add 90. 90 minus pi, 90 minus theta, 90 plus 0. So what is it? Minus pi by 2, 90 minus theta, pi by 2. So 90 minus theta is between minus 90 and plus 90. And who is the interval minus 90 to plus 90? It is the restricted domain of sin. So 90 minus theta is between minus 90 and plus 90, which is in restricted domain of sin function. And according to theorem 1, sin inverse and sin will get ignored. Then what is the answer? Pi by 2 minus theta. These two got ignored only because 90 minus theta is present in the restricted domain of sine function. Similarly, you can prove any other thing using same concept. What is it? See, for clarity, I am explaining one more in this. Cot inverse of tan theta is equal to 90 minus theta. If and only if theta is present in the restricted domain of tan. Okay, na? How will you prove it? If I take LHS, cot inverse of tan theta, the LHS, it is cot inverse of tan theta is nothing but cot of 90 minus theta. First of all, according to question, theta is between minus 90 and plus 90. But here we have 90 minus theta. First of all, what is minus theta? I have multiplied with minus na. So minus into minus pi by 2 plus pi by 2, that will come here. And minus into pi by 2 is minus pi by 2, that will come here. Then they have added pi by 2 na. Pi by 2 minus theta. So add pi by 2. Pi by 2 minus pi by 2. Pi by 2 minus theta. Pi by 2 plus pi by 2. I have added pi by 2's. So this is 0. Pi by 2 minus theta. This is pi. Pi by 2 minus theta is between 0 and pi. Is between 0 and pi. And who is 0 to pi? 0 to pi is the restricted domain of cot function. That means 90 minus theta. This is in restricted domain of cot function. Because this 90 minus theta is in restricted domain of cot function, according to theorem 1, cot inverse and cot will get ignored and I will get pi by 2 minus theta. That is why cot inverse of tan theta is pi by 2 minus theta. And where can you find theorem 1? You will find it in the previous topic. This is topic number 4. You can find it in topic number 3, the previous video. Okay, na? So in this way you can prove all the remaining properties of theorem 4. Let us go to the last theorem of the video, theorem 5. So in theorem 5, the first one, sin inverse x plus cos inverse x is always equal to pi by 2 only when x is present in the domain of sin inverse function and also cos inverse function. What is the common domain? Both of them have same domain only. Na? So for sin inverse x or cos inverse x, what is the domain? X belongs to minus 1 comma 1. Similarly, when can I say that tan inverse x plus cot inverse x is equal to pi by 2? Tan inverse x plus cot inverse x is pi by 2 if and only if that x is in the common domain of tan inverse function and cot inverse function. And we know that the domain of both of them is same. What is it? X belongs to R. And finally, the third one, you can easily guess it. Secant inverse x plus cosec inverse x is equal to pi by 2 if and only if x belongs to the domain of secant inverse x union cosec inverse x. That means the common domain of these two. Of course, domain of both of them is same, which is minus infinity comma minus 1 union 1 comma infinity. So out of these three, I will prove any one of that and you can prove the remaining two. Let me prove the third one itself. Let me prove that sec inverse x plus cosec inverse x is equal to pi by 2. So, the proof. Let me take any one of this as theta. So, I will take sec inverse x is equal to theta. Dear students, according to question, x is in the domain of sec inverse function. So, therefore, theta is in the range of sec inverse function. What is the range of sec inverse function? Theta belongs to 0 comma pi except pi by 2. All these must be remembered. Since x is in the domain of sec inverse function, secant inverse will go to the right side. We will get sec theta. And we know that sec theta is equal to cosecant of 90 minus theta. And next, if theta is between 0 and pi, if theta is between 0 and pi, including 0 and pi, and of course theta cannot be 90. What about minus theta? Minus theta is between, see, I am multiplying with minus na, minus into 0 here and minus into pi here. Next 90 is there. Let us add 90. See, it is 90 minus theta. So 90 minus, we have already minus theta na? Let us add 90. When I add 90, so what I'll get? Minus pi by 2 less than or equal to pi by 2 minus theta less than or equal to pi by 2. So I got 90 minus theta between minus pi by 2 and plus pi by 2. That means in the interval of minus 90 and plus 90. Who is this? This is the interval minus 90 comma plus 90, except again which one? See, if theta is not equal to pi by 2, if theta is not equal to pi by 2, then pi by 2 minus theta is not equal to pi by 2 minus pi by 2, that is 0. If theta is not 90 degrees, then 90 minus theta is not 0 degrees. So here also except 0. Okay. So what I am trying to say is, this is the restricted domain of cosec. So that means 90 minus theta is in the restricted domain of cosecant function. Because 90 minus theta is in this particular domain, in this particular interval, so 90 minus theta is in the restricted domain of cosec function. Therefore cosecant will come to the left side. It becomes cosec inverse x equal to 90 minus theta. Cosec inverse x is equal to 90 minus, and what is theta according to the question? Sec inverse x. So take minus secant inverse x to the left side. We got it. Therefore cosec inverse x plus sec inverse x is equal to pi by 2. The proof is over. Similarly, you can prove that sin inverse x plus cos inverse x is equal to 90. Tan inverse x plus cot inverse x is equal to 90. Some basic applications of these properties in problems. How do we use it? Theorem number 3. So it was about inverse trigonometric ratios of 1 by x na. So for example, that means what? We have seen that sin inverse of x is equal to cosec inverse of 1 by x. That is, if what is sin inverse of 1 by 2? I can write it as cosec inverse of the reciprocal of it, that is 2. Similarly, tan inverse of root 3 by 2 can be written as cot inverse of 2 by root 3. And tan inverse of minus root 3 by 2. What is it? It is cot inverse of 2 by root 3 minus pi, according to the properties that we have discussed. Okay, na? So this is about theorem 3, basic application. Next, theorem 4. How do we basically apply it? You can use it directly. What is it? Sin inverse of cos 60 degrees is what? 90 minus 60. 90 minus 60 is what? 30 degrees, which is pi by 3. Directly you can use it like this. And similarly, what is cosec inverse of secant pi by 4? Cosec inverse of secant pi by 4 is pi by 2 minus pi by 4, which is equal to pi by 4. We can directly use this. So this is basic use of theorem number 4. And what about theorem number 5? That's very easy. You will find theorem number 5 in many of the places in problems. So what is it? What is sin inverse of 1 by 2 plus cos inverse of 1 by 2? No need to find the values separately. According to theorem 5, this is equal to pi by 2. Similarly, what is tan inverse of 2 plus cot inverse of 2? We don't know what is tan inverse of 2 exactly. But according to theorem number 5, tan inverse of 2 plus cot inverse of 2 is equal to pi by 2. Over. Basically, we can use these theorems directly in the problems. That's it for today's video, dear students. So until now we have discussed 5 theorems, 5 different properties of inverse trigonometric functions. So it's very important for us to remember what is the domain of inverse trigonometric functions and also the range. Similarly, it's very important for us to know what are the restricted domains of the trigonometric functions. What is the restricted domain of sin theta, cos theta, tan theta, etc. As I have discussed in the first video. Okay, because these are being used in each and every video, each and every property. While proving properties, we are using them. So it's very important. Keep this in mind. And The concepts are very important, as I have told you. So this will enable us to solve any model problem. Okay, if you are clear in concept, you will be able to solve any model problem. So if you have understood this concept, do like this video, subscribe to my YouTube channel if you are new. So I'm going to post almost each and every concept related to inverse trigonometry, and of course even other chapters. So do share it to your friends if you feel that you have understood these concepts. Thank you. We'll continue in next video.